So we're going to look at another way to talk about a secant line. So before we had the equation for a secant line, the slope of the secant was equal to f of x2 minus f of x1 all over x2 minus x1. Now we're going to look at a way in which we can rewrite this. So let's go ahead and look at our graph. Well, that's a really straight line. That one is not straight, but it's not supposed to be straight, so we're okay there. All right, and we want to find the secant line between these 2 points here. All right, so if we identify these points, this point is x2, this point is x1, this point is f of x1, and this point is f of x2. And it's clear, we look at the change in y as f of x2 minus f of x1 as our numerator, divided by the change of x, which is x2 minus x1, as our denominator, and that's our slope. But we're going to now identify x2 in a little different way. We're going to call this distance here between x1 and x2 as delta x, meaning the change of x. So if that's the case, x2 is equal to x1, which is this distance here, plus delta x, which is this distance here. And so now we have x2 is equal to x1 plus delta x. Well, now that I have this equation here, I can then just substitute that into here to come up with another definition of slope. So this is equal to f. Well, instead of x2, I'm going to write x1 plus delta x. x1 plus delta x minus f of x1 all over x2, which is now x1 plus delta x minus x1. Well, this x1 cancels with this, and we're left with f of x1 plus delta x minus f of x1 all over delta x. And so this is another way in which we can write the slope of the secant line. And the reason we're going to rewrite it this way is to build up for what we call a derivative. So we write it out this way so it allows us to take the derivative. Well, derivative seems like a fancy term that we've probably heard of before we don't like. So I'm just going to cross this out because I think that's terrible. I don't want to freak you out yet. Give me time, we will. What this equation does, it allows us to look at a single point and estimate the slope of the tangent line. That's not bad. Here we have a slope between 2 points, and this equation is going to help us look at when we're going to look at a slope between an individual point. So the way we can look at this is let's draw out a graph. Okay, so there's our function. This is f of x. All right, and we're going to identify a couple points on this function. So let's look at this point here. We call it x1. And look at this point way out here. Call it x2. So we want to find the slope of this line here. Well, we know that. We can do that by just the change in y over the change in x, which is the slope of the secant. All right, but what is it we want to do? Well, we want to find the slope when at exactly the point x1, not the average rate of change between 2 points, but just the slope at the given point. What we want to get is the line that's tangent to x1. Well, to start that, rather than have x2 be way out here, let's have x2 be a little bit closer. So let's have this point now be x2. And what you can notice here is that in our red line, this whole area was delta x. With our black line, now this area is delta x. Delta x is going to get smaller. Well, we want to get it even smaller. So let's look at another red line right here and call this point x2. Well, now we have this distance here as delta x. It's getting even smaller. And in fact, we want to continue to do this until we get so close the delta x gets really close to 0. And this is the point that we're going to build upon to be able to find the slope of the tangent line. So again, to review, we have our function f of x, we have our secant line, which is the slope between any 2 points, and now we're going to take these 2 points from x1 to x2 and just have them slowly get closer and closer until the difference between those 2 points goes to 0.